This is Antimony. Have you ever thought about triangles? I know I have, so me and my classmates are here to explain to you the three theorems that are fundamental to modern geometry.
If two triangles are similar, it means that all corresponding angle pairs are congruent and all corresponding sides are proportional. However, in order to be sure that all triangles are similar, you don't necessarily need to have information about all sides and all angles.
The AA criterion for triangle similarity states that if two triangles have two pairs of congruent angles, then the triangles are similar.
AAA triangle similarity. The inter-angle proof of the AAA similarity criterion. The AAA similarity can be proved in the following way. The given angle ABC and angle DEF. We have angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. To prove corresponding sides are proportional, that is AB over DE and is equal to AC. And then angle ABC is similar to angle DEF. By drawing the line PQ such that is DP equals AB and DQ is equal to AC.
Let's take a look at some problems regarding AA triangle similarity. Number 1, consider the triangles below. Select ABC with a scale factor of FE over AB to explain ABC. What do you know about the sides and triangles of ABC? Below ABC is dilated about the point P with a scale factor of FE over AB to explain ABC. Corresponding angles are congruent after the dilation is performed. So P is congruent to P, therefore P is congruent to E as well. Similarly, A is congruent to A, therefore A is congruent to F, because the scale factor of FE over A.
From number 1, we know that angle B is congruent to angle E and angle A is congruent to angle F, and angle A and B is congruent to angle F and E. This means that triangle AB and C is congruent to triangle FED by ASA congruent. Therefore, there must exist a sequence of rigid transformation that will carry triangle FED to triangle AB and C. Triangle ABC equal to triangle FED because a series of rigid transformation will carry triangle FED to triangle AB and C, and then a dilation will carry triangle ABC to triangle ABC. All that was known about the original two triangle in number 1 was two pairs of congruent angles. Therefore, you have proved that AA is a criterion for triangle similarities. One pair of angle is marked as being congruent. You also have another pair of congruent angles due to the vertical angles in the center of the picture. Therefore, the triangles are similar to AA equal to.
AA triangle similarity examples. Example 1. Why don't you have to verify that all three pairs of corresponding angles are congruent in order to show that two triangles are similar? If two pairs of angles are congruent, then three pairs of angles must be congruent due to the fact that the sum of the measures of interior angles of a triangle is 180 degrees. Therefore, three pairs of congruent angles is more information than you need. Prove that triangle CB is similar to triangle GD. Note that line CB is parallel to line GD. This means that angle AGD is congruent to angle ACB because they are corresponding angles. Angle A is shared by both triangles. Two pairs of angles are congruent, so triangle CB is similar to triangle GD by AA.
Example number 2, you found that angle AGD is congruent to angle ACB. In example number 3, you found that angle BAC is congruent to angle EFC. Two pairs of angles are congruent, so triangle CBA is similar to triangle JHF by AA similarity. Example number 3, prove that triangle CBA is similar to triangle CBF. Note that line segment AB is parallel to line segment FE. This means that angle BAC is congruent to angle EFC because they are corresponding angles. Angle C is shared by both triangles. Two pairs of angles are congruent, so triangle CBA is similar to triangle CEF by AA similarity.
Street bulb is fixed on a pole 6 meters above the level of the street. If a woman of height 1.5 meter casts a shadow of 3 meters, then find how far away she is from the base of the pole. Let A be the position of the street bulb fixed on a pole AB equals 6 meters and CD equals 1.5 meters. Be the height of the woman and her shadow be ED equals 3 meters. Let the distance between the pole and the woman be X meters. Here both woman and pole are standing vertically. Hence, she is at a distance of 9 meters from the pole.
Starting with the SAS theorem. SAS theorem is when two triangles are congruent. It means that they have equal sides and angles. Hearing this definition, One might assume that all sides and angles of two triangles must be known to tell whether they are congruent. This is where the SAS theorem of triangles comes in. According to the SAS theorem, two triangles are congruent if two sides and the included angles of each are equal. The reason for this is pretty simple. If the two known sides and the included angles are drawn, there is only one value, the last side, and two remaining angles to take to close the triangle.
Triangles may seem to be just another geometric shape, with three sides and three angles. However, they are special enough to have an entire subject devoted to them, which is trigonometry.
What makes triangles so interesting is that certain sides and certain angles related to those sides that have special relationship. One of these relationships is found in the SAS theorem and the SAS formula.
SAS area formula. If the values of two sides and their included angle are known, then the SAS area formula can be used to find the area of the triangle. The formula is as follows.
A is equal to 1 half AB and C, where A and B are sides and C is their included angles. Finding the area of an SAS triangle with an SAS formula is as easy and simple as substituting variables for known values and solving for it.
Let's say you have one triangle with a side length of 5 and 10 and the angle included between those two sides is 30 degrees, and if you have a second triangle that also has a length of 5 and 10 with a 30-degree angle in between, then with the SAS postulate, we know that the two triangles must have exactly the same measurements.
This is we know that we're having to use the SAS and the formula. So, remember, hypotenuse is the side opposite to the right angle in a right triangle. This wraps up the SAS theorem. Let's move on to the second one.
SSS stands for side, side, side. This rule applies to two triangles that are congruent. According to the aforementioned rule, if all three sides of one triangle is equivalent to the corresponding three sides of the second triangle, the triangles are said to be congruent. To solve an SSS triangle, we must use the rules of cosine to calculate the measurement of the angles of the given sides.
Examples. These are the given three sides, A, B, and C. Within A is equals to 8, B is equals to 6, and C is equals to 7. You can try to find the angle of any side you like first. But for this example, we'll try to find the angle of side A.
To find the angle of side A, you must use the formula cos of A is equals to B raised to 2 plus C raised to 2 minus A raised to 2 over 2 plus C. And then you must substitute the variables with the given measurements to get cos of A is equals to 6 raised to 2 plus 7 raised to 2 minus 8 raised to 2 over 2 multiplied to 6 multiplied to 7.
After simplifying, move the cosine on the other side of the equal sign to get the angle of A. A equals cos negative 1 multiplied by 0.25. Solve it using a calculator and you'll get A equals 75.5224, so on with this. Round it up to the nearest tenth and that gives us the final answer, A equals 75.5 degrees.
After you find the measurement of angle A, we need to find the measurement of the next angle. Let's try to find the measurement of the angle of side B. The formula for angle B is cosine of B is equal to C2 plus A2 minus B2 all over 2CA.
What we did for angle A, we must also substitute and simplify the equation. Cosine B equals to 72 plus 82 minus 62 divided by 2 times 7 times 8. Cosine B equals to 49 plus 64 minus 36 divided by 112. Cosine B equals to 0.6875.
And again, the cosine on the other side of the equal sign after simplifying to get the measurement of angle, which is B is equals to cosine negative 1 times 0.6875. Bring out your calculator and solve it to get B is equals to 46.5674 and so on with it. So round it up to the nearest tenth to get the final answer, which is B is equals to 46.7.
Finally, you can solve angle C. It is the easiest to solve among the other angles since you just have to subtract 180 degrees to the answers that we got from angle A and angle B to get the measurement of angle C. The formula is 180 degrees minus 75.5 degrees minus 46.6 degrees is equal to 57.9 degrees. The measurements of angle A, B, and C are 75.5, 46.6, 57.9. If we combine these three measurements, we will get a total of 183. And that is the final answer for this video.
The best angle which to approach any problem is a triangle. Once again, we're grade 9 Antimony from Puerto Princesa City National Science High School. Thank you for watching and I hope you learned a lot. God bless you and goodbye.